All right, let's get rolling. Is it flickering? Shut up. It used to be a lot louder once you get to like 250 or 300, when it's like, hey, who's this guy just yelling at us to shut up? And it gets way more animated. Plus I burst the eardrums of the folks on here. All right, so let's look at the homework assignment here. I had a student come in and ask for some help, so I wrote this out so we'll just walk through it. But brought something to my attention, and this is hopefully it actually gives us some evidence to some things that have happened that I've mentioned in class here. You know, C++ is an older language, right? But they keep coming out with newer and newer versions. See how we have C++ 14, 17, yada, yada, yada. We have the older C++, which is based after Turbo C, which is from years and years and years and years ago. So with all that in mind, as they make little refreshers to some of these older languages, they start adding some things into them that I don't think it's fair to say makes life easier for programmers. I think it makes the transition to C++ maybe a little bit, especially coming from a scripting language perspective, a little bit less intensive. And what I mean by that is I have taught you in the slides that the syntax for ands and ors is that double ampersand and the double vertical bar. That is how it has been with C since day one. You roll back to 1968, that is what an and or is. And that is true in C++ up to seemingly recently. I mean, I have to admit, I don't know how long, because I haven't tried to write the words and or the words or in C++, presumably in years, because the syntax is that and that for an and. Now, at the end of the day, I don't necessarily care what you do. Obviously, I can look at this and say, oh, that means and, that's let's call it the correct syntax. I also know how to read. So if you type in the word and, now I know it technically functions. But even if it didn't, if you're on an exam or something like that, and you wrote out the word and, I'm not going to knock you points for the correct logic, but you wrote out the word and. That's something, if the compiler's not happy with it, it'll scream at you, you'll go and fix it, and life will move on. All right, so I don't get nitpicky with that, but it was interesting to me that it did so happen that the word and is allowed by at least this most recent version of C++. We'll run a little experiment here, but let me, actually, let's just do it now real quick. So it definitely runs under this one. Let's go to, well, we'll just go down in order. Runs in that one. Runs in that one. Now, there is just no way it's going to run. Turbo C is too old. Yeah, I mean, it doesn't know about a whole bunch of stuff in there. in Turbo Z. I don't even think we got to the end. Yeah, it dies here at the IO stream, because back then you would have had to include iostream.h. The idea of IO stream and namespaces didn't even exist. And you're seeing it. I mean, it's even having to launch this thing in like the special window, right? So it's so believe me when I say that this is a truth. My strong suggestion for you would be to get used to using the double ampersand for ands and the double vertical bar for ors. That certainly then supports this other side of the coin with we talked about the bitwise operators in here, which I also said, I'm not going to test you over, but remember, we're building this strong foundation so that through the rest of your computer science career, you kind of know when something behaves a certain way, why it's behaving that way. So the argument I would make is that C-based languages, this is C, C++, Java, C#, Objective-C, all of those languages use this as the logical and operator. Okay. The fact that the word and worked in here is fine. You're not going to lose points, but just just because something works doesn't necessarily, unless you have a rationalization as why it works. You have an argument on why it worked the way you wanted it to work. I would encourage you not to necessarily do it that way. And remember that any homework assignment I give you, I want you to solve in terms of the tools that I've provided you in class so far, because again, as a reminder, there's almost always going to be an easier way to solve some of these problems, especially as we start getting into more complex assignments. But I'm almost purposely tying one arm behind your back by forcing you to have to solve it through the tools that we have rather than some built-in things. And really that concept is the whole reason why we're using an older language like C++ to solve these problems, because there's less stuff built in. Even though we're seeing here, there's still more stuff built in today than there would have been way, 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 way back when. But it's certainly not as, let's say, evolved as something like, I was just making sure I was recording. It's certainly not something that's as maybe evolved as like a Python, which is why we purposely chose not to use Python as our first language. I'd argue it's almost too friendly and not structured enough to really give us a strong foundation. You'll see plenty of Python as you go through our program. You'll do it in the machine learning class and the AI class. And so, all right. So having said that, for our assignment today, we were supposed to just look at write a program that loops through all the numbers between 1 and 10,000. Your program should print to the screen all of the values between 1 and 10,000 that are evenly divisible by all of these values: 3 and 14 and 35. Okay, so break this down to individual pieces. First of all, we want to write some code that loops through all the numbers between 1 and 10,000. So I'm just going to go ahead and get this. For its I is equal to 1, I is less than or equal to 10,000, I is equal to I plus 1. Now, I don't necessarily care if you want to equal to or not. The question is, when I say between 1 and 10,000, maybe it's a little bit abstract as to, do I want you to go all the way up to 10,000, or doesn't matter. Close, right? We're writing a loop here that goes through a whole bunch of numbers from 1 to, in this case, I'm going 10,000, including 10,000. All right. So if all I did here was do a C out on I, this will just print out to the screen all the numbers between 1 and 10,000. It should be printing it. Was it still cooking? I'm guessing when I ran that turbo C++ thing, it probably put it into a funky mode. So I just had to stop it and run it again. So there's all the numbers, every single number between 1 and 10,000. Okie dokie. So that's the first part of the assignment. Write a loop that goes through all those numbers. Now, and this kind of goes back to this idea of asking questions, right? Or how human beings solve problems. We remember stuff, we ask questions, and we have repetition. And one of the things we're practicing with these little assignments, so this assignment is little, but some of you would have found it frustrating or had lots of errors and things like that, even though it's a tiny little thing, because you're still training your brain how to slow down and break things into little tiny individual steps. All right, so step one, go through all the numbers between 1 and 10,000. Check. Now, my program should print some stuff to the screen. Right now, I am printing everything to the screen, right? But it wants me to only print stuff to the screen that meets a certain criteria. So that's where I'm going to have to start asking some questions. I can ask a single question, kind of built in with a bunch of ands, or I could ask a nested question. We'll do it both ways so we see it. So I want to print to the screen if every value that is evenly divisible by 3, 14, and 35. So now I have to ask myself the question, how do I ask, is a number evenly divisible by 3? Okay, last class I gave you the hint where we have, when you use a single slash with integers, that gives you integer division, the whole number, not with the decimal point. When you use modulus, the percent symbol, that gives you the remainder of integer division. This is going back to 3rd grade math when you did long division. We all loved that, right? All right, so what we're looking for is numbers that when divided by 3 have a remainder of 0, because that means that 3 went into it an even number of times with nothing left over. Okay, so we'll ask the question, if a number is evenly divisible by 3, let's just print that out, just those numbers. So rather than just haphazardly printing here, we're going to ask a question. If the current number I, when divided by 3, has a remainder of 0, then print it out. All right, so now I'm only conditionally printing out this number. But at this point, I'm only printing it out for numbers that are evenly divisible by 3 only. I haven't even taken into consideration those other values. All right, so now we'll see we have a fewer number printed out. So only the ones that are powers of 3 are printed out. Okay. So before I print out here, I can say, well, you know what? If I'm inside this if statement, that means that I'm looking at a number that is evenly divisible by 3. But that's not good enough for my assignment yet, because I also need to further break that down and only see numbers that are evenly divisible by 14. The number I have right now is already evenly divisible by 3. But I can't just print it out. I want to ask another question of this number. Are you evenly divisible by 14? So if the current number, when divided by 14, has a remainder of 0, then I can print that number out. So when I print this out, this is printing out a value that meets both of these criteria. It only got inside this if statement because it was evenly divisible by 3. If this was false right from the get-go, I end up down here. I never asked this question. So if this was false, this first if statement, if it was not evenly divisible by 3, I won't even try to ask the question about it being evenly divisible by 14. I just fall past the if statement and my program ends because I have no more code there. All right, so now I'm only printing something to the screen if it's evenly divisible by 14, and I'm only even asking that question if it was evenly divisible by 3. So now I'm displaying all the numbers that were evenly divisible by 3 and 14. So there's those numbers. But that's still not enough. Simon said it needed to be 3, 14, as well as 35. So I'm going to ask another question. If I mod 35 has a remainder of 0, then we'll print out that. So if it's evenly divided by 3, we'll ask another question. If it's still evenly divisible by 14, we'll ask another question. If it's evenly divisible by 35, that means if I am in here it passed all three of those rules. Okay. And we'll print it out to the screen. So this should be our correct answer. These are the numbers that were evenly divisible by all three of those values. Okay, so we could have written it this way. Similarly, and I'll go ahead and write it in a separate, I'll write it a second time in a separate for loop. We saw last time that because for loops have their own scope, this variable I lives and dies with this for loop. So I have it available to me again, right? So I'll say for int I is equal to 1, I is less than or equal to 10,000, I is equal to I plus 1. So now I'm going to formulate another Boolean expression. Remember, Boolean expression is any expression that boils down to a single value of true or false. Even if it looks scary, it still will boil down to a single value of true or false. So I'm going to bring these three separate questions into a single Boolean expression. I only want to print something out if the current value, when divided by 3, has a remainder of 0, and the current value, when divided by 14, has a remainder of 0, and the current number, when divided by 35, has a remainder of 0. When all three of those conditions are true, when this is true, and this is true, and this is true, then I want to print out that value. Oh, sorry. Go ahead.
So that basically allows you to reduce
I don't know. That's a bit of a loaded question. It's equivalent. Yeah. Sure. So you did it like the first way.
Except I didn't do all the.
You did it this way. Okay. So you did it the wrong way. let's look at that, because that'll give us a good. Yeah, but I think you probably got a different answer. Let me write what I think you wrote, and then you tell me if that's what you wrote. I'll steal my for loop here. All right. So you asked, here, I'm just going to write it again. So if I mod 3 is equal to 0, you printed it out, right? And then you had a second question. If I mod 14 is equal to 0, you printed it out. If I mod 35 is equal to 0, you printed it out, right? No, mine's way worse than this.
Put it like in a paragraph. So like I put all of them under and then click run and then.
Okay, so that's even worse. Got it.
Okay.
let's he almost did it this way, but his works even different than this one. And first of all, that's all good, because you're gonna, by doing this, you're gonna learn a whole bunch of different ways that don't work, right? So this was all still time well spent. So he wrote that guy, right? Effectively that guy. All right. So this kind of goes back, and actually this is a good wrong answer to talk about. I had emailed him earlier, said, hey, we're going to do this little showing class. He had it right to begin with, and he says, yeah, I'm going to write it this way, and it's going to, yeah. So we worked this all out. All right. So this kind of goes back to our when we were talking about whether or not the curly braces are needed or not. Okay, because remember when we talked about whether it's loops or conditionals, that what goes along with this if statement is a single statement. All right, so the guy that's inside this if statement, actually, you know what? Hold on. I said that you did this a wrong way. It's actually right. You have the correct answer. Yeah, you do have the correct answer.
I don't know what I'm doing with this stuff.
Yeah.
When I saw the numbers pop up, I
Yeah.
started thinking,
You have the correct answer, but let's understand why. All right, because I'm going to still go back to my statement that always use the curly braces until you know why you don't need the curly braces. All right, because the idea is that with an if, this if says, if this is true, perform the next single statement. As I did up here, actually, yours matches effectively this guy. You did it this way without the curly braces. Okay, so if this is true, I'm saying perform this statement. You're saying perform this statement, which is fine. That's the next statement I ran into. If this is true, I'm saying perform this statement, the single statement, which is a collection of statements, right? Where you just said perform this single statement. If this is true, I'm saying perform this statement, which is a collection of a single statement, where you're just saying, yeah, just perform that one guy. So it just so happened, since there was only one statement per thing you were doing, if this is true, ask this single question. If that's true, ask this single question. If that's true, perform this. Now, if I were to indent this cleaner, I probably would have written it like that, because that's really what's visually what your code is doing. We're asking a question, and only if it's true do we ask this question. Only if that's true do we ask this question. And only if that's true do we do this. But because it didn't have the curly braces in it, and because you had everything left justified, you got the correct output for, let's say, the right reason. But I would say that until you really understand when you need the curly braces and when you don't need the curly braces, it's arguably by accident that it worked out. Kind of makes sense? Mm-hmm. Yep. Yeah, and that's normal. That's normal when you're starting out, because now you're just saying, okay, first of all, I want it to not scream at me, so give me some kind of output. Then let's find out, is the output it gave me something okay? If it's not, let's go almost like a Rubik's Cube, right? Let's just change a little something and then run it again and hope for the best, right? What we want to trend towards is this idea of saying, before we click run, we want to say that, okay, the change I just made was for this reason, not because I changed it in hopes that I get something different, unless you're then willing to backtrack and say, okay, I got a different answer. Now, why was it different? You might use the code to teach you something. Go ahead. Well, I did explain it last class, but I would make the argument, and I also just explained it again here, that technically the syntax for an if that's true, perform a single statement. That's it. I'm just saying, if you choose to always have that statement be a block statement like that, and even if you only put one thing in here, like we did here, this guy right here, a block statement with a single statement in it, functionally is equivalent to just having that one statement. Well, let's say yes, but here's where it becomes a difference. Because it is more than visual. That guy right there, for example. This will give you all the numbers that are evenly divisible by 3, 14, and 35. That's what we'll print here. What will that guy print? All the numbers, regardless of any questions being asked. Because this guy, even though it looks like it's part of this little, series of questions that are being asked here, this guy is not part of what occurs if this is true, or if this is true, or if this is true. This guy lives on his own outside of those things, and it would be easier to see that. Well, actually, here I can just show it up top. If I steal that line, I just come up to my first one here. Functionally, that's what that code is doing. So that's where the curly braces make things significantly clearer, even though you're having to type some extra junk. A single statement. And that statement can be of any kind of statement that's a legal statement, right? That can be a single, like, update a variable. That could be a single print statement. What I'm arguing is, if you make a habit of just always making that a block statement, and then inside there putting all the stuff, even if it's only one thing, all the stuff that you want to belong to that if statement, you're going to find far less problems. So at least for right now, good rule of thumb is, when you create an if statement like this, always put an opening, closing curly brace after it. Always. Officially, I'm telling you that's not 100% accurate in terms of the laws of this guy, but it will never be incorrect. Because worst case is you have something like this, where I did make a block statement that I happened to only put one statement in. So then you say, well, why didn't you just write that single statement? If an if says I'm going to execute the next single statement, and you actually only want to run one single statement, then we would say that this block statement here is sort of kind of a waste of time. But for human readability, I'd say it's still worth it. Especially as beginning programmers, where we're trying to cut out the number of things that possibly can go wrong. So a good rule of thumb for us would be, anytime you write a loop or a conditional, as soon as you finish that line, put an opening and closing curly brace on it. And then build your sandwich in between. Treat them like the bottom and top of the bread. Okay?
Initially, what I had done was I had put if, the question, and I put a semicolon at the end of that.
You had like this guy.
Yeah.
Yeah, that's a statement.
Yeah.
So he ran into a situation where he asked the question, but he ended that statement right there. So it always did this.
Yeah.
Because that code, even though this is a statement, a block statement that has a single statement inside of it, but it's no longer linked to this if, because this if died right there.
Yeah.
When that semicolon hit. So that's the empty statement. And these are kind of common bugs that you'll run into. And that's kind of, this goes back to day one of class when I said programming is kind of like a sport. You can academically follow it in class. You can say, oh yeah, that makes sense. You see it, like, okay, no problem. But then when you actually go out there to practice, you actually go to write it yourself, you make all sorts of little mistakes. And, so often I'll get an email or a Slack message like, I wrote the exact same code as you wrote and I got a different result. All right. I can confidently always answer that if you got a different result, it's not the exact same code. It might look real close, but there's usually some little thing. For example, this is one of those common programming mistakes where you accidentally, since, now that we're typing in curly braces and semicolons all the time, you accidentally just get semicolon fever and you're just throwing at the end of every line. And now you've changed the meaning of this code by short circuiting this if statement and saying, okay, I'm going to do nothing here as a result of that if statement. And the rest of this just works, but looks kooky. It functions, but it doesn't follow the logic I intended. All right. So does that make sense on what's going on with that? So even though it gave the correct answer, what he wrote here, this is identical to my first answer here without this extra print here at the end. It's identical to this guy, but he chose not to write the curly braces, which are not required, but are fraught with danger, let's say. Okay. The second one here, and this goes back to your original question, is this the better solution? I would argue in this particular case, this is the more concise, cleaner solution, as long as you're comfortable with, we'll call these guys borderline scary Boolean expressions. So, because that is a Boolean expression. Remember, a Boolean expression is any expression that boils down to a single value of true or false. And even though I'm asking three different things there, ultimately it will boil down to a single value of true or false. The current value I is evenly divisible by 3 and 14 and 35. That'll be a true or false statement, which then says we only are going to do this if all of this is true. Go ahead.
What's the difference between writing 2 and 1 and? Like if I thought I wrote 1 and it should be
You wrote,
just like 1 and.
oh, this guy? I mean, I guess math, well, the difference is this is doing a bitwise and on that. So the only reason that would have given you the same result is if it's mathematically equivalent. So this is saying I bitwise, actually, hold on. This is a 0 and, oh, it is because it's mathematically equivalent. So accidentally, you wrote something that did mathematically work, because if this is 0 and this is 0 and hold on a second, and this is 0, so this is 0 bitwise and 0 bitwise and 0, that should be false. This should give me no output. Because 0 bitwise and 0 bitwise and 0, this is going to give me all the values that are.
I included something else at the end, like when it's not equal to 0, but then I ran it, it would give me 0, and like the values that were supposed to be outputted. So I added like my variable was called count2, and count2 is not equal to 0. I don't know if that makes sense.
I guess I'd have to see the rest of the logic, but I mean, realistically, I would say the starting point here is that was your starting mistake. By using the single ampersand instead of the double ampersand, we had talked in class the difference between, this is the logical and operator versus the bitwise and operator, which does the mathy stuff. So if I ran this code as is here, nothing is going to print out, because 0, even if it's evenly divisible, 0 and 0 and 0 is going to be false. Bitwise 0, well, 0 bitwise and 0 is going to be 0. 0 bitwise and 0 is going to be 0. So that makes this guy false, so we won't print anything out here. This is effectively a math problem. It happens to, so that's not even a Boolean operator. That's not a Boolean expression, because we say the definition of a Boolean expression is any expression that boils down to a single value of true or false. This guy boils down to a number, because bitwise and creates a math thing, gives us a number. Yeah. Yeah. Yeah, I mean, yeah, so the difference here is if we do this as a while, so that's what yours looks like. Okay. Now, what is the difference? Output will be the same. So you're right, you got the right answer. But what is the difference between this one and this one? This one would allow me to do that. This one would not allow me to do that. So this variable I died when this for loop ended because it was defined as part of the for loop. We're doing this as a while loop, which isn't a problem. He was forced to define the variable outside of the while loop, which now makes it belong to the scope of main. It did not die when this while loop ended, which means I was still able to print out the current value of count. In this particular case, we weren't interested in printing out the current value of count or the current value of I, so made no final difference. But that would be like kind of the functional consequence of doing a while loop instead of a for loop. Made no difference in here. And you're never going to lose points from me for doing it in a way that makes sense to you and works. I'd much rather have a less pretty or less efficient correct answer than a really cool looking wrong answer, right? So always do it in the way that makes sense to you. Don't necessarily say, well, what do I think he's expecting? I'm expecting for you to grapple with it until you ultimately get the right answer, or at least learn a whole bunch of stuff that doesn't work. One of those two things. Go ahead. Mhm.
One, how do you play this itself?
Doesn't.
It doesn't? Okay.
No.
That wasn't sure.
They don't get their own scope.
Okay. I know that you could just go down to the reason.
Yeah.
I was wondering if that was for its own little scope for it.
Doesn't.
Okay. I just wanted to check.
Mhm.
The question is, what's the order of operations for Boolean expression? If you went through
Yeah, left to right.
left, right. So
Yeah.
if I want to do this block of and or this block of and, I'd have to.
Correct. And actually, it's a good question. It doesn't really impact us here,
No.
but for example, well, it actually would. It potentially it will happen behind the scenes here. Let's just get rid of this guy so we're not confusing it, because this is doing a math problem. So basically, for a very long time, possibly forever, you are never going to write a single ampersand or a single vertical bar when you're coding. So you can right now in your mind say that's a mistake. It gives you an output, but it's giving you an output for the wrong reason. That's doing that bitwise stuff, which I've said this is what's actually happening under the hood, but that's not something that you're going to hardly ever, if ever, do in code. But every now and then it is possible to do, and there could be some legitimate reasons for it, but unrelated to any problems that you're going to solve for a long, long time. So let me get rid of that. So if we look at, let's get rid of, well, I was doing this in multiple places. Oh, I changed that to. Let's get rid of, well, the while loop's fine. So this guy right here, if this first and let me see something here. If this first and, or this first Boolean expression fails, because I'm doing an and, it won't even ask this question. It won't even try to ask that question. Okay. In order for an and to be true, both sides have to be true. And if the first question we ask is false, it is then impossible for this and to be true. which means we would be wasting our time to ask the next question. And the programming languages know this. That's built into it. And that becomes an important thing that you might use in the future, relatively soon for us here, because you might be asking the question, you might say, if a collection has something in it, and the first thing that's in it is even, do something. And that's going to be an important thing, because if the two questions you're asking is, if it has something in it and something else is true related to the thing that's in it, do something. But what if it doesn't have anything in it? If it didn't have anything in it, then asking that next question is going to end up being an error. You have an empty collection and you're saying, well, I already asked the question if there's nothing in it, and there isn't anything in it. But now I'm going to go ahead and ask some stuff about the thing that's not in there. You say, well, go ahead and give me the thing at bucket 0, which I'm not going to find. So now I'm holding nothingness, and I'm asking some questions about nothingness, which is just going to give me errors. Don't try to compartmentalize it into anything right now. Just for right now, leave that out there in the ether and just say the fact that an and says that everything needs to be true. As soon as we get to something that's false, we stop asking questions. Unrelated. All we're talking about here is what I have highlighted. Just Boolean expressions. In a Boolean expression, if we're dealing with ands, as soon as we run into something that's false, we stop checking. Similarly, if we're dealing with ors, as soon as I run into something that's true, we stop checking. Because an or just says at least one thing needs to be true. I don't have to waste my time asking additional questions if I already ran across a true statement. Yeah. You want to do this and this. That would not give you the correct output. It would give you an output, because this would say print out. This would give you the same output. And so I still have that one written as this guy. If it meets any of these criteria, print it out. Actually, it would give you almost, it wouldn't give you the same output as this. It would give you close to the same output as this, because this guy would give you duplicates, right? Since we're asking this question multiple times, if I run into a number that is evenly divisible by 3, 14, and 35, it will print out all 3 times here. I'll hit each one of these if statements will fire. Yeah, because these are not, this if is not an else to this. This is just a whole nother series of questions. I'm asking 3 completely separate questions here. And all 3 of them can potentially be true. So up here with the, where did I write the or thing, as soon as, if this guy's true right here, I won't even ask the rest of this, because this is an or, and I'll just go ahead and print out I. So this would print out all the numbers that are only evenly divisible by 3 and potentially not evenly divisible by these other ones. So this would only print out the numbers that are evenly divisible by at least one of those values. It would capture the ones that are evenly divisible by all of them, but it also would capture all the ones that are evenly divisible by only 2 of them. And also capture all the ones that are evenly divisible by only 1 of them. We just get all those guys. Go ahead.
So we're mixing and what?
Left to right. That's where your parenthesis thing would have to come in.
I have 3 and divided by 15 or 35. Just gonna check the go by 3 and 4.
Yeah, it'll do this first. And if this is true, it won't even ask the second half.
But if it is true,
But if this is false, it'll still ask the second half, because this ors can be true if the left half was false. But to your point, if you wanted it to do the or first, then you would need to do that. You could say, look, I want to ask this or question first, and then I want to ask this in an and with it.
Could I just structure it the other way out?
Yeah, you could. Then it would go left to right. Yeah, so effectively what he's asking is how do orders of operation work when it comes to those Booleans, just like math stuff. Okay. But now so if I'm comparing that to the rule of thumb that we're talking about, like curly braces, I could say just always use parentheses when in doubt. And if you always use parentheses when in doubt, it'll make sure that it does the things in the correct order. The order that you intended. Whether that was correct or not, it'll do it in the order that you intended. Go ahead.
I'm just curious if you like how.
Oh, you private messaged it to me. Count 2 is not equal to 0. Oh man, this is really weird. So you're creating a variable called count2 and you're not initializing it to anything. So count2 here is a variable that does have a default value probably of 0. Right? Right. But you never gave it a starting value. Then you're saying int count2, you're redefining count2 and you're starting it to be equal to itself, the previous version of count2. So we actually have two versions of count2 here. One that belongs in the more global scope, and then another one that was born, lives and dies with that for loop. So this count2 does what's called shadows this count2. So this count2 is kind of temporarily put on hold because inside here, whenever we say count2, we're talking about this guy. And this guy is getting initialized to whatever the previous value of count2 was, this guy, which you never gave it a value. It would be, I believe, 0. That's usually what the default value for an int is. But you can't rely on that. If you want it to be a value, you need to give it a value. So we're going to initialize count2 to whatever the default value is of an int. And then we're asking the question, as long as this guy is less than 10,001, so this goes all the way up to including 10,000, do something. Then you're going to update count2. This is this local version of count2 to be whatever it used to be, this local version plus 1. So assuming it started off at 0 accidentally, right? We're going to keep going from 0 all the way up to 10,000, including 10,000. So that's what this for loop does. Now, each time through, we're going to ask a question about this count2. So we're saying if 0 mod 3 is equal to 0 and 0 mod 14 is equal to 0, and these are bitwise ands, and 0 mod 35 is equal to 0. So 0 mod 3. So 0 divided by 3. 3 goes into 0 0 times with a remainder of 3. So this is a false. This is a 0. And a 0. And a 0. And count2 not equal to 0. The very first time through, count2 will be equal to 0. So you will fail this the first time through, but then it becomes a 1. So then you'll be able to ask the questions. Oh, see, this will always be true then. Because, yeah, this will end up always being true because the second time through here, count2 will be equal to a, let's see, count2 will be equal to the number 2. And I'm saying the number 2 is not equal to a 0. Or it actually will be a 1 the second time through. Is it true that 1 is not equal to 0? Yes, that's a true statement. So this is true that count2 is not equal to 0. Now in C and C++, Booleans are represented as numbers. So true is anything non-0. Usually it's represented as a 1, is a true. Okay, so this is 0, bitwise and 0, bitwise and 0, bitwise and 1. So that last one said it'll be 0 with a bitwise, which will come out to 0, which should be false. So this should print out nothing.
Like if you run it, if you run it, then it's probably.
Yeah. Let me just do this. Let's just do this inner thing here. Let me gut some of this stuff here. Well, I don't know, I'll leave it in there for some examples. Let me just give myself a little divider line here so I can see where stuff is starting. That's line 40. That's got to be, I must have been in the middle of explaining something up here. Oh, this was that count code. When I was showing I was asking what's the difference between these. Get rid of the while loop. Actually, just for a minute. Okay, so it does look like the correct output. Well, I want to find out. So if this is okay, so this is my Boolean expression here. I'll put this in parentheses just because it didn't need it, but so this is what yours will do the second time through the loop, where count 2 is equal to 1. 3 goes into 1 0 times. 0 mod, or so with a remainder of 3. 3 goes into 1 0 times with the remainder of 3. 14 goes into 1 0 times the remainder of 14. So we're saying 3 bitwise and 14, bitwise and 35. These are the remainders. Take this guy out. If I say 2, actually, I'm going to switch it to 3 here for this. It's still always a 0. Yeah, so that always comes out to a 0. This is saying if 0, do something. I'll make sure it gives me a 1. Does. So if this is always a 0, that will always be false. Because if I say if 0, print out that, nothing should print out. Yeah, nothing prints out because that's a false. If I say if 1, which is true, it'll print out the value, which is a 1, because 5 is equal to 5. So if this guy is always 0, this should never print out. Go ahead.
So,
Right, because it's doing the math behind it. And it just happens to be asking the same question in a mathematical way, not in a logical way. And it happens to work because that is the mathematical way of asking whether it's evenly divisible. Accidentally. I assume that's not what you were trying to do. It's just, it's just
I just saw the right answer.
yeah, no, it is interesting.
That's how I was just curious.
Well, so I think you're right. I think under the hood here, this is asking the same question in the math way instead of the logical way, but it's giving the same answer. But this is actually the reason why we talked about those bitwise operations, because now in this case, the moon's aligned and we got the right answer, right? But let's assume, let's just throw a curveball. Let's just assume that one of those values in there happens to be the wrong answer. So you got almost the right answer, but then one little curveball. Now you look at it and you would rather have gotten an error message screaming at you for not doing A, B, or C, right? And in a newer language, you would have here, because this bitwise and with a true or false statement here would not work in like Java. Java protects Booleans and doesn't treat them as mathable things. So Java won't let you do addition, for example, with a true or false value, even though under the hood, they're represented as zeros and ones. C++ will. So in C++, we can do a bitwise and with a true or false value, because true or false is a 0 or a 1. Yeah. So C++ would allow you to do a bitwise operation with an actual Boolean type, when usually bitwise operations are done with numbers, because under the hood in Booleans, it is a number. So this would have crashed in a language like Java, because this guy would be true or false, not a number. But because we're not using Java, we're using an older language, C lets this fly because it says, look, it's a Boolean, sure, but it's a number. Okay, under the hood, it's a number. And you're asking me to do a math problem. We can do math problems with numbers all day long, right? Okay. Now, forget about the fact that this happened to ask the same mathematical question, even though it was done without the logical question. Is it evenly divisible by this? And is it evenly divisible by this? And is it evenly divisible by this? Instead, we've represented the mathematical equivalent of creating a single value of 0 or 1 in this if statement mathematically by mapping all three of these things together, which happens to give us the same. We are asking the same question. It just happens that the math worked out, which is fine, but it wasn't your intention, right? So, but that's almost where the danger comes in with using the bitwise operators, and why I made sure you were aware that these guys are doing math problems, not logical Boolean questions, because what we're seeing here, even though it happened to be the right answer, it didn't give us an error, right? Then, well, yeah, well, not just that, but you might now get used to this, and now you're using a single ampersand all over the place. The next time you try to do it and it doesn't happen to have the math moons line up, where you're solving the same math problem. Then you get the wrong output and you don't know why. Because it's not going to scream at you in C++. It'll give you the output it thinks you asked for. And you're like, well, that's the wrong output. Why? And you didn't recognize that this guy was the bitwise AND operator instead of the logical AND. I think same thing. Python, that's a bitwise AND, but Python doesn't let you do math with Booleans. All right. But the reality is what we're really talking about here. I don't want to get, this is clear. This is an outlier. So you don't need to like memorize all these little nuances and stuff like that. What I'm trying to do is I'm trying to give you a path towards getting used to this stuff in the simplest ways, and then leaving these outliers for the oops, I made a mistake situations. That's why I'm saying with a if statement or a for loop or a while loop, always use the curly braces, right? If you always use those, you won't have these accidentally did something, accidentally got the right answer. If you always use them. Same thing. If you're doing anything with Booleans, always use the double ampersand. As far as you're concerned right now, that single ampersand doesn't exist. When you decide to allow it to exist in your world again, at that point in time, you'll have enough programming maturity where it will make sense to you. Right now, it's just going to muddy the waters. That makes sense? Yeah, so the defense aspect of this is to, even though we've talked about quite a bit of technical stuff here, I'm really showing you the pitfalls of the things that you want to try to avoid. And if you just follow a couple of rules of thumb, you'll be able to mostly avoid them. Always use curly braces with a if and a loop. Always use the double ampersand or the double vertical bar for ands and ors. All right. And then I guess the third thing is based on a couple of things you've asked is if you've had some programming experience before, don't try to say, oh, is this like this other language? Or is this like this other language? Keep your focus in that here's the tools I have in front of me. I'm playing in the C++ sandbox. This is the tools that I have. Solve those problems. Because once you get a programming competency down, when you dive into a different language, you'll say, how do I define variables? How do I ask questions? How do I do repetition? And now you can already solve a whole bunch of problems with that new language, even though you were just introduced to it. And then when you run into little weird stuff like this, like I'm telling you in Java, this would have screamed at you, then you can say, oh, because this was this weird outlier, now I can spend a couple of minutes investigating this, but because I already have a foundation in computer programming, that's not like this weird, I don't know, scary thing. You know, I already know what I'm doing, and now I'm just kind of saying, well, why did I get that output? And you're running kind of a little experiment. That makes some sense? All right. So yeah, interesting one. All right, so reality here is that I would have expected that your answer would have been something like this or something like this. Or potentially accidentally, but not necessarily wrong, something like that. So we'll call this one the correct answer that's living dangerously, right? Because since we avoided using those opening and closing curly braces, we're very reliant on the fact of, did I really know why this guy worked, or did it just happen to work? Make some sense? So this would be that example of, hey, you have an if statement, you don't have an opening and closing curly brace, you should be highly suspicious of yourself right now. Always use that opening and closing curly brace until you can say, okay, this is a waste of time, I don't want to have to do this, right? And I've been programming since I was 9, and I still use the opening and closing curly braces all the time now, except for every now and then if I'm doing something called an inline if statement where it's not really allowed, I'll avoid doing it. But I would write the opening and closing curly braces for something like that. I think it just looks better, even though it's not required. Make sense? So it's not like a cop out, in my opinion. It's reasonable coding style. All right. So let's see. Let's make sure we only have good answers up here. So we'll call that one good. We'll call that one good. Yours is right. If you, I would say, yes, yours is good and smarter than me. If you had sat there and said that, okay, yeah, I mean, you know, like this programming is new to me, but I'm like a math savant. And, you know, I just, this is how I deal with ands and ors. Right? This is my world. You know, I just see things kind of living in the matrix. Right. And it's like, yeah, this is what made the most sense to me. Then maybe, but it feels like we kind of just stumbled into a correct output for, I'm sure, mathematically sound reasons, but not necessarily what you meant. Let's see, this guy is a decent one to look at. I mentioned it once already, but let's just look at this again. This is the wrong answer because it's going to print out at least once every value that evenly divides any of these. And the ones that evenly divide all of these, it'll print out 3 times. Because I'm asking 3 completely separate questions here. This question is not related to this question, is not related to this question. They're not like ifs and elses. I'm walking up and I'm asking 3 completely separate questions, regardless of what the answer to the previous one was. Not illegal. You know, it's syntactically accurate code, but it's not going to give me the result that I wanted. So let's take that guy out of there. We'll call this guy living dangerously. Dangerously. Okay. And this guy, yeah, I don't even know about that guy. That's living even more dangerously. Okay, unless you knew what you were doing when you wrote that, and if that's the case, then that's, yeah, you want to maybe do some sort of, you know, test out of something, or you know, head in some research thing, you know, like the guy from Good Will Hunting. Have you seen that movie? Have you seen Good Will Hunting? You walk by the chalkboard, some impossibly to solve math problem. Here's the janitor. Done. Yeah. So this is kind of his neighborhood. If this just mathematically makes sense to you. Yeah. So let's get that guy out of there. We'll call that a happy accident. I did like this one as a good class example. So yeah, I'm glad we worked that out ahead of class. Because this is something that I'll see very often from beginning programmers, is because they'll do something until they get the right output. And sometimes because you didn't already have that habit of just saying, I always need an open and closing curly brace when I have an if. I always need an open and closing curly brace when I have an if, so on and so forth. You have these 3 lines that aren't indented or anything. So you're kind of at the mercy of like, well, do these do what I think they do? Well, the output's correct, so yes, but not really knowing why. All right, so let me throw this up on Slack. Okie dokie. Well, we got nowhere today. This was your defense against not having a homework assignment for Thursday. It's like, look, just ask tons of questions and give them some random mathy stuff. And it's like, we will not have homework then. It's all right, hold on. Let me just see where we're going next. Okay, so we've done So the next thing we're going to be looking at is functions. Actually, you know what? Let's look at collections first. So I'll start talking about them here. We have a, oh, I hate that. That's Apple for you. Like, I can't add anything or save this document because there is an update to this program. And the thing is, they're going to make me close this program in order to run the update. Yeah, I don't think it'll let me save though. That probably would work. What did I just do? Look at that. Yeah, see, I can't add anything. I am actually offline. Oh, you mean offline? Yeah, that probably would work. All right, here, I'll just show it to you in code since that's not going to be connected to it. So the next thing we're going to look at, I kind of mentioned a little bit something about it today, is this idea of a collection. So the first thing we're going to look at is something called an array. So an array is a collection of values stored under a single variable name. And I'll cover this again next class. I just want to show you a quick code example in our last couple of minutes. All right. So I'm going to go ahead and I'm going to create a collection capable of holding 10 numbers. So I'm going to say int my numbers 10. So what that does there is it creates for me a single variable. The single variable is called my numbers, and it's capable of holding 10 individual integers. Just put the multiples of 5 in there. So we'll have a 0, a 5, 25, so on and so forth. All right, so there's my 10 numbers. So here I'm creating my collection. I'm going through and I'm filling it up with some numbers. What numbers am I filling it up with? All the powers of 5. 0, 5, 25. Actually, no, I'm just adding. Am I adding? Okay. So I'm filling it here. I'm printing it out here, just showing that I'm going through everything in that collection. And this is how I extract a value from that collection. This is how I put values into that collection. So next class, where we're going to start is we're going to talk about what's actually happening under the hood when I create this array. All right, we're going to be talking about something called contiguous memory. All right, questions, comments, concerns, bribes. All right, no homework for Thursday. I will see everybody then. Yep, take care. That's fine.